Black holes are the ultimate machines of destruction. Well, they were. Until they met the internet, that is, which resulted in memes. Hey guys, welcome back to the channel. Today we shall be doing black holes. So this is our second video on the channel and we hope you enjoy. If you guys want a part 2, comment down below and leave a like. Before we start, I think we should go over some common misconceptions. First off, black holes aren't actually galactic vacuum cleaners. In fact, if you were to replace the sun with a black hole, nothing would really happen, apart from it'd be really cold. A black hole far away with say 10 times the sun's mass will pull on you just as hard as a normal star with that same mass. If you keep a safe distance, a black hole can actually be orbited. Orbiting a 10 solar mass black hole would be like orbiting a 10 solar mass star, except not so hot and bright. So the big question is, how do black holes form? So in the core of stars, nuclear fusion crushes hydrogen atoms into helium atoms, releasing a huge amount of energy. In the form of radiation, this pushes against gravity, maintaining a delicate balance between the two forces. So as long as there's fusion in the core, a star remains stable enough. But for stars with way more mass than our own, the heat and pressure at the core allow them to fuse heavier elements until they reach iron. But iron doesn't generate energy, so it builds up, and with no more fuel to burn, the star cools. With no nuclear fusion, the outer parts of the star are violently expelled in a supernova explosion. The core collapses under its own weight, and if the core, after the supernova, is very massive, no known repulsive force inside a star can push back hard enough to prevent gravity from completely collapsing it. So the core compacts into a point with virtually zero volume, infinite density, which is also known as a singularity, where not even light can escape its gravity. I know it's confusing, but, well, it's a black hole, and those get weird.
Black holes are also incredibly complex and they're made of various parts. Some of these parts include the event horizon, or otherwise known as the point of no return. This is the point where once past, nothing, not even light, can escape the gravity created by the singularity. Then there is the singularity itself, the point in space where matter is so compressed it causes for there to be this immense gravity. There are gravitational waves. Gravitational waves are something that we still don't fully understand ourselves, but we know that they're only created by incredibly powerful objects with incredibly high amounts of gravity. Then there is plasma, that is created by matter that is being super compressed, heated, and sped up at such a speed due to the black hole's gravity that it causes for it to superheat. There is then the electromagnetic emissions that come from the poles of the black hole, so basically incredibly powerful waves of electromagnetic energy. And that sums up just a few parts of a black hole.
So there are two main types of black holes. The first black hole is called a stellar mass black hole. These range between 3 to 12 times more than the sun's mass. If this black hole feeds on more matter, it becomes more massive, meaning that the black hole gets bigger. The gravity of this black hole acts strongest on the part closest to it. So if you were to get too close, your feet would stretch as the gravity is strongest there. This term is literally called spaghettification. You'd become kilometers long, but as thin as a hair. But if you're thinking of falling into a black hole, then I would recommend you fall into a supermassive one. Well, anyways, I don't think nor you, your friend Joe, or even your dog should go anywhere near a black hole. Well, you know, because of the instant death thing. The second type of black hole is called a supermassive black hole, and as the name says, they can be between millions, even billions of times larger than the mass of our own sun. These are usually found at the center of galaxies and were usually formed when galaxies were formed. So, if you were to fall into this one, because the gravitational strength is so large, it would act on your whole body and not just on one part.
One of the most energetic and yet terrifying events in the entire universe is caused when two black holes merge. Now, when two black holes merge, there are two possible scenarios or events that can occur. In the first event of two black holes merging, They get closer and closer until eventually they lock onto each other in a fierce grip. As this is happening, the time dilation occurring goes off the charts. Now, for those of you that don't know what time dilation is, it's essentially the slowing down of time caused by there being a hyper amount of gravity in one point in space. Anyway, eventually the two black holes get so close that the event horizons touch, creating an initial surge of energy. After this, the singularities of the two black holes merge, creating one much larger black hole. As this happens, and the two singularities meet, it creates a surge of energy so powerful that it contains more energy than all of the stars in the entire observable universe in that moment in time.
There are two outcomes to the collision of black holes, and as Nicholas said, the first outcome is that they would come together to create what is known as a binary black hole. But what would be the second outcome? So the two black holes would have to be spinning at very high speeds and come together at just the right angle. The smaller black hole would be slingshotted away from the bigger one and sent hurtling through space. So the second outcome is definitely better than the first, but still, nobody likes a black hole hurtling through space at extreme speeds.
And finally, the death of a black hole. What is strange is that most people seem to think that black holes are everlasting, but this really isn't the case. In fact, a black hole, much like everything else in our universe, dies. It just takes an incredibly long time to do so. Black holes are constantly losing energy. This happens when two particles that are joined fall into the event horizon of a black hole. In the process of one of the particles being consumed and falling into the event horizon of the black hole, the other, in a one-way reaction, shoots out in the opposite direction, taking some of the black hole's energy with it. This energy is expressed as radiation. This radiation is now happily named Hawking radiation, after the famous Professor Stephen Hawking.
Hey guys, thank you so much for watching today's video. So it's been a little bit longer than usual, reason being today we've covered the topic of black holes, and not only are they extremely complicated, but there's still tons of stuff we don't know about them. Also, we haven't simplified everything about black holes, so there's still lots of stuff we need to do. And if you guys do want a part 2, don't forget to leave a like and comment down below. Also, subscribe if you like where our channel is going and you want more of our content. And in a sec, we'll give some shout-outs out.
Thank you guys so much for watching the video. We hope you've enjoyed. And, as usual, we'd love to give a big shout out to Elias, Daniela, and Sam and Olivia Miklazovic.
So yeah, once again, thank you so much for watching. We hope you enjoyed, and we'll see you in the next video. Bye guys.